So hi and hello there. Welcome to the new video of the course, and in this particular video we are going to see different parameters that are involved while designing any amplifier. Okay, so from this particular video we had started the amplifier section, that is how BJT can be used as an amplifier, right? Okay, so we'll straight away jump to this particular point, that what all parameters plays a crucial role by designing an amplifier. But before coming to this particular point, we need to understand that what exactly is an amplifier. So let me write the basic definition of an amplifier. So the definition is the main task. It is not a definition, but the task, what exactly an amplifier does. Okay, the main task or the main work, the main task of any amplifier, of any amplifier, the main task of any amplifier is to amplify a weak signal, a weak signal weak signal. So basically what does the amplifier does, it converts a weak signal into a stronger form. All right, so as you can see over here, this is a BJT transistor. I had drawn a rough diagram. Okay, the amplifier cannot be represented in such a form, but to this particular diagram will help you to understand this particular concept in the easier way, right? So that's why I had drawn this particular diagram. Okay, so as you can see over here, to the input of the BJT, what we had done, we had applied a weak AC signal. Okay, so basically what we can conclude from this particular diagram is that we can only amplify a weak AC signal. We cannot amplify DC signal. Okay, because DC signal cannot be amplified. Okay, we can only amplify a weak AC signal. So this is what we can conclude over here. But that's the different scenario. We'll first understand that what exactly it is doing over here. So as you can see, we are applying a weak AC signal to the input of the transistor, and at the output we are getting an amplified form. Okay, although that's a different scenario, that at the output of BJT we would be getting an inverted form of this particular waveform. But for your understanding purpose, I had just drawn this particular waveform as it is. Okay, so basically remember one thing, although I had shown you that why exactly this particular signal would be in the inverted form, that is the phase shift between the input and the output waveform would be 180 degree. But right now, for your understanding purpose, I just drawn this particular waveform as it is. Okay, and as you can see over here, just by looking at this particular waveform, you can easily conclude that this particular waveform, it is getting amplified over here as it is to the output side. Okay, so let me write over here. So this is your weak AC signal, weak AC signal. Okay, and this is your strong AC signal. So your strong AC signal, right? Strong AC signal. Okay, I hope you understood this particular part, that what exactly is an amplifier and what it does. Okay, so basically it converts a weak AC signal into a strong AC signal. Okay, great. So now we'll move to the parameters, like what all parameters are involved while designing an amplifier. Okay, so the very first parameter that is involved, it is known as voltage gain. So we'll see what exactly it is. So if you could remember the third mini project, where what we had done, we had actually applied an audio signal to the input of the BJT, and at the output the LEDs were glowing on and off continuously, right? So remember one thing, this particular audio signal is in millivolts. Okay, and what we had done, we had actually amplified the audio signal. Okay, and due to this, what was happening, the LEDs were glowing on and off. So let me write it over here. This particular AC signal can be an audio signal or can be any signal. Audio signal, for instance, audio signal. So audio signal is in few millivolts, and then what we are doing, we are converting this millivolts of signal into few volts. Okay, then you will ask me, sir, why we are doing so? Like what exactly is the need of an amplifier? So for that, let me move to the further page. Let me explain you this particular concept over here. Okay, just a second. Yeah, so for that, since I'm a biomedical engineer, I can give this particular example or explain this particular example very well. Okay, so let's suppose this is your heart. Okay, I'm not so good in drawing, or there isn't any such romantic thing going over here, but for your understanding purpose, I'm drawing it roughly. Okay, so let's suppose this is human heart. Okay, human heart. Okay, And we all know that from heart we are able to obtain an ECG signal. Okay, from heart we are able to obtain an ECG signal. ECG signal. ECG signal can be obtained or is obtained. Okay, and this particular ECG signal, it is something like this. That is, this is your P wave, something like this. I know some of you all guys, you are not that much familiar with the biology, but you know, I hope that you might have seen this particular diagram somewhere. Okay, something like this. This particular waveform is something like this. Okay, and this is your T waveform, right? So I had drawn it roughly. So this is your P, this is your Q, R, S, and T waveform. Forget about everything. Okay, forget about everything. So what is the amplitude of this particular ECG signal? So let me tell you, the amplitude of an ECG signal is, just a second, the amplitude of an ECG signal, write it somewhere over here. Let me move this particular T wave above, just a second. Yeah, so this is your T wave. Okay, so the amplitude of an ECG signal, it is how much? It is 1 millivolts. It is 1 millivolt of signal. It is 1 millivolt of signal. Now let's suppose we want to analyze the working of heart. Okay, for that we need to understand this particular signal, right? But now since this particular signal, it is in its weak form. Okay, it is having very low amplitude, or the amplitude of this particular signal is very less. Okay, and as I told to you, see how we are obtaining this particular ECG, obviously with the help of one electrode. Okay, there are different electrodes, but for our understanding purpose, what I had done, I had just connected only one electrode. Electrode is nothing but a sensor which can sense this particular signal. Okay, electrode, right? And there is high amount of chance that this particular signal, you know, it may lose certain energy. Okay, so instead of 1 millivolts, we might obtain 0.8 millivolts, 0.8 millivolts of signal, 0.8 millivolts of signal. Now you will say there is hardly any difference, like we were expecting 1 millivolt, but we are getting 0.8 millivolts. Okay, but due to this, what is going to happen? You know, due to the internal loss, as I told to you, the, you know, if you could remember the sources, types of sources, there I told to you there is some internal loss over here. There is loss of voltage. Okay, so basically there is loss somewhere over here. Okay, due to the internal resistance of electrode or maybe heart. Okay, we are only able to obtain 0.8 millivolts of signal. So there is loss of 0.2 millivolts of signal, right? So due to this reason, we need one amplifier. Why? To study what? To study the characteristic of this particular signal. I hope you are getting my point, my dear student. Okay, just a second. So to study the characteristic of this particular signal, okay, we are analyzing the working of heart. So basically what I can write, or I will write in different way, depending on the shape of waveform, depending on the shape of waveform, we are able to analyze the working of heart. We are able to analyze the working of heart. Now you will tell me, sir, how we are able to analyze the working of heart. So I know you are not that much familiar with the biology part, but you know how this particular RVO is generated because of maximum contraction of heart. So whenever the heart contracts, okay, it is getting squeezed. Okay, it is getting squeezed, and due to squeezing, what is going to happen? This RVO is going to produce. Why? Because maximum of the blood is going to the aorta over here, and over here it is going to the pulmonary artery, if I'm not mistaken, if I'm not knowing that particular concept in depth. Okay, because it's high time that I had not read the biology part, but this blood, it gets pumped up. Okay, and this particular RO, it resembles that there is maximum contraction. So I'll write over here, it resembles that it has maximum contraction, and this we can study, only with the help of what, only with the help of this particular signal. Okay, so maximum contraction produces R wave. I will write over here, produces R wave. Okay, now you only tell me, if this particular R wave, it is not maximum in the amplitude, then how we are able to obtain this particular conclusion, or how we are able to conclude this particular thing. So for that very purpose, we need an amplifier. Okay, so basically designing of any amplifier is required to extract the signal. Okay, and after extracting the signal, we need to convert that particular weak form of the signal into a strong form. So what we are doing over here, see, I'll write over here. So let's suppose, just a second, let's suppose this is your amplifier. Okay, this is your amplifier. Okay, and what you had done, from heart you had just a second, yeah, so let's suppose this is your heart. Okay, this is your heart, and obviously with the help of electrode, although there are lots of circuitry involved in between amplifier and this particular thing, like signal conditioning circuit and all that, we will study in the sensors part. Okay, but right now for your understanding purpose, I'm taking this particular example, right? So this is your electrode. Okay, electrode, and there are many electrodes. There isn't any single electrode, right? Like you will study in your higher school, maybe if you are in biomedical engineering and all, we'll send central triangle and all. Okay, so we need not worry about that particular part. Okay, with the help of this particular electrode, what we are able to achieve, we are able to obtain this particular weak signal. Okay, this particular weak signal, we are able to obtain this particular weak signal. Okay, which has what, which has magnitude of 1 millivolt, or amplitude, I would say amplitude of, I'll take different color, just a second, yeah, which has amplitude of 1 millivolt. Okay, which has amplitude of 1 millivolt, and then this particular signal, it is fed to what, it is fed to this particular amplifier. So this is fed to this amplifier. Okay, so this particular signal, it is fed to what, it is fed to an amplifier, it's fed to amplifier, and to the output side of this amplifier, what we are able to obtain, just a second, yeah, at the output side, what we are able to obtain is this. See, so at the output side of the amplifier, we are able to obtain the magnified or the amplified form of this particular weak signal. Sorry, something like, it would be something like this. Okay, I'm drawing with my rough hand, so it won't be looking that great, but please try to understand. And now for our understanding purpose, I will take any rough magnitude, so it would be roughly around 1 volt. Okay, it would be roughly around 1 volt. So are you able to understand this particular thing? What we have done, this particular weak signal, it is of 1 millivolts. Okay, and we, like before introduction of this particular amplifier, we were not able to obtain the characteristic of this particular signal. Okay, by studying the characteristic or the shape of this particular waveform, we are able to analyze the working of heart. But before amplifier, we were not able to do so with this particular weak signal. So what we did, we just made one amplifier, and then we fed this particular weak signal to the input of this particular amplifier, and at the output side, we got an amplified form of this particular waveform. Okay, as you can see, the shape is also same, just the thing is that it has, the magnitude of this particular waveform has increased. Okay, from 1 millivolt to 1 volt. Okay, and this will help us now, like just by looking at this particular waveform, we can conclude lots of things. Okay, how it is contracting, so maybe P wave is generated. Okay, so basically blood flows from the upper part to the lower part in P wave. Okay, I'm not able to understand, like I'm not able to recollect that the exact working of the heart as of now, but yeah, I had learned in my college days and also. For that very purpose, we need to design one amplifier, right? Just by looking at this particular shape of the waveform, we are able to understand the working of it. Okay, I hope you understood this particular part. Okay, so we'll come to this particular uh, concept. Okay, so this is your audio signal. You can take any signal. In our case, like in our example, it was ECG signal. Over here it is an audio signal. Okay, so this particular audio signal, see, it was in millivolts. You had increased its voltage to certain volts, right? So basically what we need to understand over here is what is the voltage gain of this particular amplifier. So basically over here we need to understand the voltage gain. So let me write over here voltage gain of an amplifier or voltage gain of this particular system, and over here the system is nothing but a BJT, right? Amplifier. So over here we are need to understand voltage gain AV. Okay, it is denoted by AV. You need to understand the voltage gain of the system. So over here, what is the formula of voltage gain? See over here, voltage gain. That means what? What is your gain exactly? What is your gain? So it is denoted by AV, right? So how we are supposed to write that? It is equivalent to your V out, okay, divided by V in. So if you could see over here, your input voltage was in few millivolts, okay, and you are able to obtain a voltage which is in few volts. So basically your gain is nothing but 1000 in our case. I had just given you a rough example, okay, and so for that very purpose I had intentionally taken this millivolts and volts. Okay, you can also go with microvolts to millivolts. Okay, there are certain signals like in your brain, the brain produces certain signal that which is known as EEG, electroencephalogram. Okay, it is in few microvolts. Okay, so you have to be very much causal about that particular signal because that is very sophisticated task. So, and generally the waves produced, that is beta, alpha, gamma, all these waves produced by the brain, it is in few microvolts, right? So you need to convert this particular microvolts of signal maybe in millivolts or volts to analyze that particular signal, as we had learned over here. Like just by looking at this particular shape of the waveform, we are able to analyze the working of heart, like right, like our wave generated due to the maximum contraction of heart. Okay, on similar way, just to analyze your sleep patterns and all, we have to analyze the working of, we have to analyze the shape of the brain waves. Okay, and so for that very purpose we need to understand the voltage gain. Okay, I hope you understood this particular part. All right, so now moving further, so basically voltage gain is nothing but your overall gain. That means if you are supplying weak signal, okay, and if you are getting a strong signal, you just need to divide those particular thing and then you will get the voltage gain. I hope you are getting my point. Although this particular concept I will explain it in much depth in the amplifier section. Right now we are just understanding what all parameters are involved over here. Okay, so obviously see, if you are giving voltage, obviously there would be some current going to the system. Over here it is BJT, and by current I don't mean IB. Okay, I don't mean base current. This is input current. That means the current generated due to this particular voltage source or the AC signal, right? So I denoted it by I in. So now if your voltage, see over here, if your input voltage is in few millivolts, so obviously your current would be in few milliampere. Okay, just for example I am taking it, it would be in few milliampere, right? And since at the output side you are getting the signal into few volts, so obviously what we can expect is that the current that is produced at the output side, it would be in few amps, right? Amperes, or over here it is in milliampere, and at the output side we are able to achieve signal such that it has voltage in few volts and few amperes. Extremely sorry for that. So basically what we can calculate over here is this. That means what? Over here we also need to calculate the current gain. Okay, current gain. See over here what we had done. At the input side we were fetching the input voltage, right? which is in few millivolts, and at the output side we were able to get the output voltage which is in few volts. Okay, and basically this is known as what? Gain. So basically whenever you will come across this particular term gain, so gain is nothing but output by input. Let me write over here gain. I will take different color. Gain is nothing but gain. Remember one thing, gain is nothing but output parameter by input parameter. It depends on what you are working with. So over here we were working with voltage, so that's why we named it as voltage gain. Similarly over here we are working with current. As you can see, I need to check what like if I'm giving certain amount of current, so at the output side how much amount of gain I'm getting, right? So for that I had named it as current gain. Okay, oh, sorry, let me change the color. Current gain, and basically current gain is equivalent to I out by I in. I out by I in, right? Out by I in. Just a second. Yeah, I out by I in. So your output current is in few amperes, right? At the input side you are getting few milliampere, right? So again the gain is 1000. Okay, again you should not keep in your mind that the amplifier would always give gain as 1000. Okay, it can give gain hundreds, it can give gain in 10, it can give gain in maybe 10,000. It depends on your application, right? So over here I had intentionally taken milliamperes or millivolts so that you should understand that why exactly we are studying this particular thing, right? Just a second, let me smooth down. Yeah, great. Now moving further, so now see, we all know the Ohm's law, and by Ohm's law we all know that V is equivalent to I into R, right? I into R. So over here we know the input voltage that we are giving to this particular BJT transistor or the amplifier in general. Over here we also know the input current that we are fetching to this particular amplifier, right? So we all know that what is V in that we are giving to the transistor and what is I in, right? So we have these two parameters, but we are not aware of this. So with the help of these two parameters we can easily calculate this one, R in. So the third parameter which is important, it is known as input resistance or input impedance. So this parameter also plays an important role while designing any amplifier, right? Let me erase it. Yeah, on similar way, if I'm coming to the output side, so again by applying Ohm's law we have V out is equivalent to I out into R out. Just a second, I out or the output current into R out into R out. Okay, so your input impedance, I'll write over here, it is also known as input impedance or resistance, input impedance or input resistance, and generally it is denoted by Z in or R in. In most of the books you will get that it is denoted by R in, but in few of the books you will also get that they had referred Z in for the input resistance. Okay, and for the output impedance or the output resistance, output impedance or resistance, you will see that you will see that it is denoted by Z out or R out. Okay, so these are the four important parameters which you need to remember, or basically which plays a very crucial role while designing any amplifier. So as you can see, this is your input resistance and the output resistance of an amplifier. So just a second, let me write over here this one, that is this particular one, this first one. This is your first parameter, voltage gain. This is your second parameter, current gain. Let me change its color. This is your second parameter, that is current gain, and this is your third and fourth parameter respectively, that is input impedance and the output impedance. Let me move it little down. Yeah, so this is your third and fourth parameter respectively. So this is your third parameter and this is your fourth parameter respectively. Okay, so now I hope that you understood this particular concept, that what all parameters are involved while designing an amplifier, and I also hope that you understood this particular topic. Okay, and I had intentionally explained you this particular topic in depth because I want that you should understand that why we are learning this particular topic, what is the significance of this particular topic. Once if you understand this particular topic, then it would be absolutely easy for you to deal with analog electronics. Why? Because analog electronics deals with amplifier, rectifiers and all, although we had not studied few of the topics which we are going to study in the upcoming courses, so you need not worry about it. But I really hope that you understood or you at least got a basic idea about amplifier and the significance of amplifier. Again, I am explaining you or we'll revise it once again so that you should remember this particular concept in depth. Okay, so the main task of an amplifier is to amplify a weak AC signal into a strong AC signal. Okay, and while analyzing parameter, before coming to the parameters, we'll study why exactly we need amplifier or the significance of an amplifier. So as I told to you, since I'm a biomedical engineer, I know the working of heart a bit. Okay, I'm not aware as of now because I had not revised this particular concept, but in general I have a basic idea. So basically from heart to heart we connect one electrode, and from electrode we are able to gain this particular ECG signal. Okay, or we are able to receive this particular ECG signal. Okay, that is electrocardiogram signal. We are able to obtain this particular signal which is in few millivolts. Generally it is of 1 millivolt of signal, but somehow we are not able to achieve this 1 millivolt of signal. Why? Because there might be loss of few millivolts because of the internal resistance of electrode or maybe the internal resistance of heart, right? Because over here your heart is acting as a source, right? Voltage source, I would say. So it might happen that we might lose certain signal. So over here, like depending on the shape of waveform, we are able to analyze the working of heart. But over here, as you can see, it is in few millivolts, and there is a high amount of chance we are not able to achieve this 1 millivolt of signal. Rather, somehow we are able to achieve 0.8 millivolt of signal, right? So for that very purpose, we need to amplify this particular signal. Okay, which can be amplified once if you are feeding this particular signal or weak AC signal. Over here, why it is AC? Because it is moving with respect to time. As you can see, it is not constant, right? So basically over here what we are doing, whatever the signal that is coming from the electrode, that is 1 millivolt of ECG signal, we are feeding it to the amplifier and then it is amplifying the signal. And then we can clearly see that over here, just to explain the concept, this R wave, what it does, basically the R wave resembles that there is maximum contraction of heart. Okay, and during this particular maximum contraction, R wave is produced. Okay, and this T waves indicate that there is relaxation of heart. That means the heart is about to relax or it is repolarizing. Okay, I know you might be not that much familiar, but just talking in layman's term, that maximum contraction, lub dub, I hope you might have aware of that particular sound, lub dub, lub dub. So basically the maximum contraction takes place during R wave. So this is what we can study once if we amplify the ECG signal. Okay, and as I told to you, for that we need this 4 parameter, that is voltage gain. That means what? The heart signal is in millivolts and then we are converting it in volts. That means what? We are studying about the gain. Gain means what? Output by input parameter. Over here, since we are dealing with voltage, so it is known as voltage gain. Similarly over here, when it comes to current, it is known as current gain. It is nothing but again I out, that means output current divided by input current, right? And over here again the gain is 1000 in this particular scenario. Okay, and since we are aware of this and this, so we can easily calculate the input resistance, okay, and output resistance as well. And again it plays a very significant role while designing an amplifier. Okay, so I hope that you really understood this particular concept in depth, and if you have any doubts, if you are still facing any query, feel free to ask me at any time, maybe in the comment section of YouTube or maybe in the chat section of Udemy, because I'm going to post this particular video in both of the in depth. Thank you for listening patiently.